So this is part C for the Chatelier's principal experiment. In this one, we have to first make our solution. Let me shift some stuff here. All right, so I'm gonna take and add to my beaker, I'm gonna add 50 milliliters of distilled water. And then I'm gonna add two different substances. So this first one, I don't know if you can see, is clear colorless substance, if you can see it there better. And this one is the potassium cythionate, KSCN. So I'm gonna add that to the water. There's no change. And then I'm going to also add, that was 1 milliliter of iron 3 chloride. And it's kind of this like orangey color, right? You can kind of see it in its original bottle here. All right, so I'm going to dump this in here. And it goes from this orangey color, you can see it changing. I'm going to give it a stir to this red solution. And it is see-through. You can see through it. Oh, maybe it's hard to tell on the camera, but maybe you can see that. Okay, so I'm going to add this solution to 5 test tubes. One of them is going to be the control, so we'll keep that one the same. And then we're going to add 4 different things, 4 different stresses to the other 4 test tubes. What we just did, the reaction kind of that we're looking at is the iron from the iron 3 chloride reacts with the cythionate ion. And, excuse me, it's going to make iron cythionate with a -2 ion. This one is what we're looking at right now in the beaker. This is the red solution that we see. Okay, so I'm going to measure out. I'm going to rinse this out for a second. I'm going to measure out 5 milliliters. Come back down here. Approximately, it doesn't have to be very precise. We're just getting qualitative data. Okay. All right, so I'm going to add this to here. All right, and then I'm just going to use my dropper to get about the same amount in each of the other ones. All right, so based on color change, just like in the last one, we'll be able to see which way it shifts. Does it stay at the red side, that iron thiocyanate ion, or does it shift back to our original substances? So we don't necessarily know what color that is right now. We just know it's going to be a change from what we're looking at. All right, so we'll keep this one. Number 1 is the control. So number 2, it says to tube 2 add 20 drops of more iron 3 chloride. So if I add more, so I increase my iron ion, you can see it really just kind of stays red. We get a little bit of a, maybe it looks like precipitate because some of that iron 3 chloride has some cloudy solid, but very similar. So it looks like it stays this direction. It shifts this way, the same way as this one. Let's add to tube 3, let's add more KSCN, the thiocyanate ion. You can see this one, it gets darker red. Still looks like it's still on that red side, okay? All right, so it's shifted the same way. Let's add now potassium chloride. Let's see if the potassium has any part of it, right? Or the chloride even, right? Because we had iron and chlorine, and we have potassium and thiocyanate. So let's see if this is any sort of factor. It says to add some solid. Okay, so a few crystals. All right, so this is tube 4. It doesn't look like any change, so it doesn't look like this does anything. Okay, so then how about something which doesn't seem to have any part in the reaction that I wrote? This one is sodium phosphate. Sodium phosphate monobasic, and I believe the equation, yes, is on in the procedure. So if I add a little bit of this, see if that makes a change. Ooh, and we have a change here. Totally changed color. So that must have shifted the opposite of these three. So if you know which way these went, you should know which way this one went, the opposite way. Okay. So one last thing, let's finish part A. So part A, I had to warm it back up to room temperature. So I did. So it had crystals after it cooled. And now that it's warmed up, it's dissolved again. So knowing that this is an endothermic reaction, we can figure out which way it's shifting. So I'll tell you that it's endothermic, and that you have, I'll do this one in blue. Let's see, we've got KNO3 as a solid, but when it's dissolved, right, it's aqueous, you're gonna have your potassium and your nitrate ions. So if it's endothermic, you gotta know where your heat is, and then cooling it and heating it, how does that affect this shift? Right now, just a quick tip or a hint, right now is when you see it all dissolved, that would be on this side, right? Where you have ions that are dissolved. When it was crystallized, like we saw before when it was cooled, that would mean this was present, so it shifted towards this. All right, so that is Le Chatelier's principal experiment.